Now, we've been talking about the normal curve or normal distribution, and there's actually a specific normal distribution we talk about a lot called the standard normal distribution. So I want to talk about this for a little bit. So there are infinitely many normal distributions, each with its own mean and its own standard deviation, right? Because you can have any mean and you can have any standard deviation as long as it's not negative. But we have a very special one where the mean is 0 and the standard deviation is 1. And in this case, this is called the standard normal distribution. So your mean is 0 and your standard deviation is 1 in this specific distribution. Now, what ends up happening is the horizontal scale of the graph for the standard normal distribution is actually z-scores. So instead of that horizontal axis being all your x values, so whatever variable it is that you're looking at, the standard normal curve has z-scores along that axis. So basically, we can take any normal curve we want and change it to the standard normal curve by converting all our x values to z-scores if we want to. And I have that formula for a z-score rewritten here, so you know how to find your z-scores. We're just going to take our value, subtract the mean, and divide by the standard deviation. So we can convert any regular normal curve to a standard normal curve if we want to. So here's your standard normal curve. Notice it looks exactly the same, but the key here is that center, right? That mean is at 0. And then for your inflection points, again, that standard deviation is going to be 1. So it's a normal curve, but with very specific mean and standard deviation. And then what ends up happening here is that your axis is not going to be the x-axis, it's going to be the z-axis using z-scores. So when each data value of a normally distributed random variable x is transformed into a z-score, the result will be the standard normal distribution. After this transformation takes place, the area that falls in the interval under this non-standard normal curve is the same as that under the standard normal curve. So basically what we're saying here is that if you have your data as a regular normal curve, or if you change it over to z-scores and use the standard normal curve, the areas and the probabilities are the same. So it doesn't change your result or the area in any way. You're just transforming from x values to z values instead, but your areas are all the same. In section 2.4, you learn to use the empirical rule to approximate areas under normal curve when the values of the random variable x corresponded to -3, -2, -1, 0, 1, 2, or 3, standard deviations from the mean. Now we'll learn to calculate areas corresponding to other x values and using that formula I showed you before to find z-scores. Now, the reason you may want to have z-scores instead of x values is basically so we can use a table to help us find those areas and probabilities. So what we have is we have tables created, and there's one in the back of your book I'm going to show you in a minute, that actually can help us find specific areas under the curve for different z-scores. So that's why you may want to change from x values to z values, is because I have all the probabilities and all the areas computed for most z values already. So that's why we make that change. I will note, though, that now with technology, it's not really necessary to always do that. So I'm going to show you how to use the table, but also how to use your calculator to find those same probabilities. So you can use one or the other, and you should get the same answer. Sometimes there may be some rounding differences. So the table in your back of the book is always rounded, whereas your technology will give you more decimal places. So you may see some slight differences because of rounding issues, but otherwise the values are all the same. I like this study tip as well, just worth noting. It's important to know the difference between x and z. The random variable x is sometimes called a raw score and represents the values in a non-standard normal distribution. So your x values would be your raw data. So that's your actual units from your raw data. So if you're looking at heights, it's the heights. If you're looking at weights, it's the weights. So the x values are your actual raw data calculations and values and things like that. Whereas the z values takes that raw data and changes it all into z scores. So it's the same information, but just in different ways of thinking of it. So just some properties to keep in mind. And again, I'm going to show you how to use that table and how to use your technology in just a minute here. But the cumulative area is close to 0 for z-scores close to negative 3.49. Now, when we're talking about cumulative area, it means from the left, okay? So remember that most of our data falls within 2, if not definitely 3 standard deviations from the mean, right? 99.7% of your data is within 3 standard deviations. So you have most of your data right here in the center. So in this first example here, we have our normal curve. We're looking at the value of z equals negative 3.49. And it's going to be way on the left. So when you have your standard normal curve, that center is at 0. So your negatives are on the left and your positives are on the right for the z-scores. So when we're talking about a cumulative area, they mean from the left. So they mean this area coming in from the left under the curve. So the area is very close to 0 here because that value of negative 3.49 is kind of really far to the left. Again, most of our data is between negative 3 and 3, almost 100%, right? 99.7%. So if you're going beyond that, on the left side here, there's really not that much data there, so that it's close to 0. The area increases as your z-score increases. So as that z-score moves to the right, then you have more area under the curve. So when we talk about cumulative area, it's always shaded from the left specifically. When z is equal to 0, your cumulative area is 0.5. So for instance, so here is 0. Okay, so we're shaded on the left. Again, we're at 0. So you can see that about half the area is shaded in, right? It makes sense that it's 0.5 because you have half your area. The whole thing is equal to 1. So when half our area is shaded in, you have about 0.5 there. And then the final one, I'll draw this little picture down here. So again, here is 0. And then, I'm just going to estimate it. 3.49 is way out here on the right. So when you're looking at the cumulative area, again, you're shading in from the left. So all of this is going to be shaded in. And you can see that almost the whole graph is shaded in, right? Not quite the whole thing because you do have this area over here, right? That would keep going, that's not shaded in. But most of your area is shaded in. So your area is very close to 1 at this point. We have almost the whole thing. So as you're getting further to the right for those z-scores, more area is shaded in when we're talking about cumulative area. So you're getting close to that 100% or that value of 1. Now, in addition to the table, and again, I'm going to show you the table in a second, you can use technology to find these cumulative areas for a z-score. And it's really quick. I do recommend, checking it out and trying it. And the steps to do it are right here. So I'm going to just focus on maybe this example for now. We're going to do some more examples to make this a little bit easier to see. All right, so here's my calculator. So what you're going to do is you're going to hit second bars, and then you can use the normal CDF calculator. So second, and then that bars key right here. Now, before we use the PDF one, that's not the one you want. You want the one that says CDF. C stands for cumulative. So you're doing that whole area under the curve here. And what you do is you enter a lower bound and an upper bound, and then you enter your mean and your standard deviation. And this works for all sorts of problems here. And then it's going to give you the area. Now, some tips here: if your lower bound is unbounded, so if you're shading something less than, you can use negative 99999 for a negative infinity. Or on the other hand, if you're going up to positive infinity on the right, you can use like 99999. Once you get beyond that, it's not going to make much of a difference in your calculation. So if you just use a really large number there, it will be fine. So let me try the second example here, just to show you how it works. So we're going to let our z-score be 0, and we're going to see if we can get 0.5. So I'm going to take my normal CDF. Okay. Now, if you look at the picture here, I can see that there really is no lower bound, right? It would keep shading left forever. So I type in my lower bound first. So I'm going to use negative 9999999. It really doesn't matter how many nines, just use like 5 or 6. And then I hit comma. Now my upper bound here was at z is equal to 0, right? So my upper bound is 0. And then I hit my comma. And then what I do is I always type in next my mean and my standard deviation. Now my mean here is 0, and my standard deviation is 1 because we're talking about the standard normal curve, right? Our mean is 0, our standard deviation is 1. So when I finish that, I'm just going to close my parentheses and hit enter. You see you do get that value of 0.5. So I can do this for all my different z values. So I could try this one here, right? I do normal, our second bars, normal CDF. Now my lower bound here, there wasn't one. It would keep shading down. So negative 99999. My upper bound here was negative 3.49. My mean was 0, and my standard deviation was 1. And you can see here, I get a very, very small number. Now, if you see that e to the negative 4, that means to take that decimal point and move it 4 spots left. So a negative means to move left here. So you're getting 0.00024 as your answer. So very close to 0, like we had. All right, so let's actually do some other values here and get some practice in. And we're going to use our calculator, and we're also going to use the table. All right. So find the cumulative area that corresponds to a z-score of 1.15 using both the table and technology. So I'm going to do technology first just because I have my calculator out, and then I'll do the table afterwards. I will say, though, that I do like to always draw a picture. So if I'm using z-scores or normal curves, for me, I like to draw that picture. So I'm just going to draw just a quick little normal curve here. I know my center is always at 0 when I'm doing z-scores. If you see z-scores, then you're using that standard normal curve. Center is at 0. All right, now my z-score is 1.15. So think about it. My center's at 0, negatives are on the left, positives are on the right. So it doesn't need to be exact, but I'm going to make sure I put it on the correct side. So positive is going to be on the right. So maybe it's about right there. And then we're looking for the cumulative area. So cumulative area means always shaded to the left. So I'm looking for this area here. I'm going all the way left, and I'm stopping at z equals 1.15. So I'm going to use my calculator first. So I hit second, bars, normal CDF. All right, now my lower bound. There is no lower bound, right? It's all the way to the left. So I'm going to use negative 99999, comma. My upper bound, where does my shading stop? It stops at 1.15. My mean is 0, and my standard deviation is 1. So for those z-scores, your mean is always 0, your standard deviation is always 1 when we're talking about normal curves. I hit enter, and I get about 0.874928. I'm going to go ahead and round to 4 decimal places, which is pretty common. Now, this makes sense. So that 0 mark is the halfway point, which is the 0.5 mark. So it doesn't make sense that we're over half, but that we're not all the way at 1, right? All right, and let's do this one too. So find the cumulative area that corresponds to a z-score of negative 0.24. So again, for me, I like to draw that picture. I'm talking z-scores, my center is at 0 here. I want a negative z-score, so I'm going to be on the left. This is a pretty small number, so it's not going to be too far from the mean, but again, it doesn't have to be perfect as long as I can kind of get an estimation of where I'm drawing that, maybe about right here. And if it says cumulative area, you're looking at the area from the left. So we're coming in from the left and we're shading all the way till we get to that z equals negative 0.24. All right, using technology first. I hit second bars. Again, and then CDF. My lower bounds is negative 99999. My upper bound is negative 0.24, right? Because that's where my shading ends. My mean here is 0, and my standard deviation is 1. And when I hit enter, I get about 0.405165, so 0.4052 if I round to 4 decimal places. And again, this makes sense that it would be less than 0.5 because the halfway point is at the 0 and we haven't reached it yet. So it's just a good idea just to check to see if you're going in the right direction there. So this makes sense that our answer would be less than a half because we haven't got to the halfway point yet of the curve. I want to show you how to do it on your table. So let me take out that giant table. I haven't ended up flipping through the textbook right now. So your table here is actually 2 pages long. There's one table for your negative z-scores, or one page for your negative z-scores and one page for the positive z-scores. So I'm going to do my best to try to show you them one at a time. All right, so the first value I'm doing, remember, is z equals 1.15. All right, so here is what that table looks like. This is table 4. It's in Appendix B of your text, or if you have the physical text, there's like a nice little insert at the end too. And so I'm looking for z equals 1.15 here. So when you do your z values, it's a little tricky, but they give you the leading values on the left, and then they give you the hundredths place up top. And you can see the picture here. So you can see the picture matches really what we already drew. It's going in that same direction. We're just looking for z equals 1.15. So on the table, see on the left here, you have your beginning values. So my value is z equals 1.15. So I need the 1.1 first. And then that hundredths place is from up top here. And then you're going to go across and match. So when I match these up and I come down here, I see my value is 0.8749, which is exactly what we got before. See right there. There's an 8749. 8749. Okay, so again, it breaks it up a little bit strangely. So your first 2 digits are on the left here, so I need the 1.1, but then my value is 1.15, so that 5 comes up top, and then you're matching up your row and your column. All right, so let's do the next one. The next one was negative, is it 0.24, so 0.24. So in your table, again, there's 2 pages, so there's another page here that's for the negatives. Sorry, I'm going to see if I can fix my camera a little bit. All right, so that's a little better. So you can see again that area is shaded in just like we did. So we did that same graph, and my negative values are here, and I want negative 0.24. So the first set of values I need is negative 0.2, and that is down here on the bottom. And then the 4 is going to be up top. So now I'm going to go down and match it up with that value here on the bottom. So I get, I'll make sure I match this up correctly, 0.4052 for the area. And that was what we had here, 0.4052. Okay. So again, I see on the left, I had that negative 0.2, and then that 4 is on the top. So I have to kind of roll down that column and match it up. And then I can see my probability there. So that's how you can use the tables. So you're welcome to do it however you want. In the homework and stuff, I don't care if it says to do it one way or the other, it's your choice. So if you want to use the table, you can use the table. If you want to use technology, you can use technology. I personally much prefer technology, but the tables can be quick and easy to use as well. So once you get used to them, you can go ahead and do that.